Hello and welcome. This is Eric Corey Freed. This is the Living Green Educational Series for Technion, and this is the formal recording of it. Um, if you were on the live event today, I'm glad you asked questions. If not, feel free to email me questions later on. I'm going to introduce myself, even though Tracy Bacchus did a lovely job introducing me. Essentially, I'm a green architect, and for the last 25 years, I've been helping people figure out how to build healthy, regenerative buildings. Along the way, I've written 11 books, and I get to lecture all over the country. And it's my honor and privilege to get to talk to you all today. And My firm is called Organic Architect. I've also been involved with many nonprofits along the way, most recently with Living Future Institute, and then even more recently with Eco Districts. And if you're into the Twitter and all that other stuff, you can do that here, or feel free to email me. Okay, let's begin, shall we? First of all, I want to thank you for being interested in sustainability at all. Quite frankly, to me, it is the most important thing we can do in our buildings. Every building should be a healthy building. Every building should be a regenerative building. We need to do that. And Technion has really been a pioneer and leader in that arena with their commitment to sustainability, to health, transparency, and it's been my privilege to get to work with them on some of that. Um, Also, I just love their products. I mean, look, this is their Montreal showroom, which I'm a big. I mean, I'd like to live here. Look at that; it's a great looking apartment. The thing with sustainability is that it means different things to different people, as it does to you, I imagine. I went to I gave a talk recently, and a guy came up to me afterwards, and I could just tell by his body language that he was defensive, and um, and he started arguing with me, and he said, I don't know what the big deal is with the sustainability stuff. I grew up in a house with asbestos and lead paint, and I turned out just fine. Uh, no, you didn't. You're pretty messed up, actually. You're pretty weird looking. You should see a doctor, really, because we're not. We've essentially toxified ourselves, and we're now paying the price for it. In fact, if I wasn't here talking to you, I'd be just cowering in the corner, rocking in the fetal position, hiding under a leaf. I think, waiting for the impending doom of the giant meteor or whatever is going to end up killing us. But I realize that our role as architects and designers is really to prevent a grim future. What I've realized is really what we're trying to do is we're trying to give you Star Trek and not Mad Max. That's the future we're trying to create for you. One that's bright and shiny and clean and abundant versus one that's scarce and frightening, really. But the path that we're headed is really in the wrong direction. This little device is affectionately known as the tree hugger. It's a marvel of engineering. I mean, in fact, it does in about 30 seconds what it used to take 50 men an hour to do. It's incredible. But imagine if we applied the same ingenuity to saving trees as we did to destroying them. Imagine if we applied the same ingenuity to healthy buildings as we did to toxic ones. In fact, this machine reminds me of one from our childhood. Do you remember? I don't know if you remember this one. It's kind of eerie, actually, how close it is. Okay, you get it. So the story I'm going to tell you today is about the XPRIZE and my recent work with them. And the story is going to sound a little crazy, but I promise it's all true. And it's really kind of a journey that I went on over the last year. Now, if you haven't heard of the XPRIZE Foundation, don't be surprised. A lot of people haven't. I've discovered, but you've heard of their work. So they're a nonprofit. They're based in LA. And over 12 years ago, they launched an X Prize for space travel. The founder, Peter Diamandis, wanted to travel into space, but he wasn't an astronaut. And he realized nobody was working on this. So he launched a very simple prize: $10 million dollars to the first person that designs a spaceship that can carry three people 100 kilometers in the air, return them safely, and do it again 2 weeks later. Very simple, very clear, very elegant finish line. 6 teams competed for that $10 million prize. 6 teams spent about $100 million competing for that $10 million prize. It took a few years, 7 years if I remember correctly, But eventually, a team won it. This is Burt Rutan, the guy that's in blue with blue jeans with the champagne bottle. He's the winner. He created Spaceship One. There's Peter Diamandis, the founder of XPRIZE, in black. He always wears black. And then Richard Branson, the guy on the right. You know him. Um, so that's what they do. They do these incredible competitions, getting people to focus on an area that people aren't necessarily paying attention to, but should. They incentivize what people are not working on. So, out of the blue last year, I received a phone call, and they said, "Would you design for us the X Prize for healthy buildings? We need to know what it is. We'll give you a schedule, and you have until October 1st to be precise, and we'll give you a budget. But essentially, you and your team will create what the X Prize for healthy buildings should be, and we'll give you two fellows from Deloitte and two grad students, and they'll make up your research team." And when you present in October, you'll present at our annual summit with eight other teams working on eight completely different prizes. So they have a prize on conquering cancer, one on Lou Gehrig's disease, one on desalinization. It's really kind of amazing. So these eight other teams, we all work together, and they picked these incredibly smart, interesting, incredible people that I was honored to work with, and we all got to kind of pitch what our prizes should be at this summit. Now, to give you a sense of scale, their annual summit is all of their advisors, all their board members, and their board members include people like Elon Musk, Larry Page from Google, Dean Kamen, Craig Ventnor. I mean, the most remarkable, smartest people in the world essentially are on the board and advisory board. So it was a tough room, but that was pretty exciting. So what I'm going to show you is I'm going to show you this X Prize for healthy buildings and how we came about it and how we did it and what I learned along the way. And when we presented it at the summit in October, we also had to create an experience room. So this is my experience room. It's kind of trippy, right? Very earthy, crunchy. There were samples of healthy finishes and materials all over. We also had probiotics in the air. So the room smelled very good, but also you felt better the more time you spent in it. And there were exhibits all over. This is me presenting it on stage in front of about 1,000 people in LA. And there were incredible people in the room, and I got to spend 3 days with them hearing their insights into this. The founder of Uber was there. The founder of one of the founders of Airbnb was there. Lots of tech people like that, but also a lot of celebrities. I won't mention a lot of names, but there is one I need to mention just because it's a funny story. Pharrell was there, and he was dressed just impeccably. I mean, everything he was wearing was so awesome. His shoes were like bespoke, homemade. It was incredible. But after I presented to him, he came up to me and he was asking me questions, and he had a lot of really hard questions. By the way, I said to him, "What do you know about biology and construction?" And he knew a lot. He knew more than me, I think. But I said, "Can I tell everybody that this is your favorite prize of the nine? Can I tell everybody?" And he said, "No, no, you can't tell. Don't tell people that at all." And I said, "Okay, can I at least tell them that we're in your top three, like your top three favorites?" And he's like, "Fine." And so later that night when I got on stage again, I said, "Hey everybody, Pharrell says we're in his top three, so you can all suck it." And everybody booed. So it was kind of fun. But what I want to show you is a little piece of some of the presentations that we gave and really get into our research. And my hope is that it'll change how you look at buildings. And here's how it begins. The way we build our buildings is stupid. It's really dumb. It's a 200-year-old technology and involves a lot of resources and a lot of effort and a lot of labor. We mine natural resources out of the earth, and then we put them on fossil fuel-based ships and trucks, and then we schlep them all over the planet. And when they arrive on the site, they're not ready to go. They then need to be assembled piece by piece by piece. Every building is a bespoke prototype, essentially. Every building is a one-off. And we're not benefiting from the technologies of modular construction or GPS or CNC fabrication or robots or any of that stuff. We're still building the same way we built 200 years ago. And somewhere along the way, we managed to make the building somewhat waterproof, somewhat thermally efficient, but not really. They're not great. And that's the problem. Within all of construction, there's this little tiny subset called green building. And honestly, that circle is way too big. I'm being too generous. Green building's nowhere near that big in relation to construction, but but there's a potential exponential revolution that's about to occur, and it's going to pass us by if we don't tap into it. A revolution involving biology, DNA, and health that could transform how we build our buildings and could transform radically the entire paradigm of how we construct anything. And so that's our big idea, essentially. And we call it, da-da-da-da, Wonder Woman, we call it prostruction. Prostruction is the opposite of construction. That's really it. It's designed to be positive. It's designed to be healthy. It's designed to essentially build the way nature builds. So I'm going to show you our XPRIZE first, and then I'll explain how we got there. Generally, it's pretty simple. Grow us a wall, an 8-foot by 8-foot wall. Right? That's a good size. Have it match all the typical properties of a regular wall in terms of weight and strength and fire rating, but add in certain biological features. Maybe it glows, maybe it heals itself, maybe it absorbs CO2 or VOCs. Do this in 6 months and win $10 million. Again, very simple, very clear finish line. Now, I should tell you a little bit about my background. I used to work for students of Frank Lloyd Wright. Mr. Wright called his architecture organic architecture. He even used biological terms to describe what he was looking at. Right? He said that a building would grow from its site, that it would respond to its surroundings. And so for my entire life, my entire career, I've been waiting for this promise of true organic architecture. One of my other mentors is Malcolm Wells. He was the father of underground building. Malcolm believed that we had a responsibility, a duty, that if we're going to build something, we're going to scrape the site to build a building, that we have to restore the nature that we've destroyed in the process. But most buildings don't do that. Most buildings are put together essentially by hand, brick by brick. We've been building the same way for 200 years. And the way we build is just through brute force, just bam, 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 right? We just hammer it all together and somehow it works. But these buildings are not very healthy and they're not very good outside, and they require a lot of maintenance and a lot of effort because we're essentially fighting entropy all the time. In addition, we build the same way everywhere. We just crap out these buildings, and whether it's in Arizona or Alaska, it doesn't really matter. We build them the same way, and we've been doing this now for 2 centuries. And if you don't believe me, here, look. Here's a building from 100 years ago, and here's today. They're exactly the same. It's the same technology. Really, I mean, the computers inside are nicer, but that doesn't affect the building. The base building is the same. I would show you one from 1817, but cameras hadn't been invented yet. Do you see how far behind this is? You could essentially resurrect a zombie from the Civil War, put him on a job site, and he'll go right to work. I mean, it's, in a certain sense, that's convenient and helpful. But it really shows you how far we've strayed. And we didn't know 200 years ago what we know today. We didn't know about indoor air quality. We didn't know about asthma, about cancer, about endocrine disruption, about any of those things that we now know. So none of that was really designed to address those issues. In fact, in most cases, it makes it worse. So it makes you think, as John Oliver would say, how is this still a thing? It doesn't make any sense. Now, we know a few things are going to happen in the building industry. We know that materials are going to continue to get more and more transparent in their materials and ingredients. Technion's already been leading the way with that. We also know that materials will continue to get less and less toxic, less and less bad. But they'll never be good for you, right? It'll never be like taking a vitamin. And they'll continue to get better and better sourced. We also know that building codes will continue to get less and less prescriptive, more and more proscriptive, and much more focused on performance-based. And that's already happening, right? In California, all new residential buildings have to be net zero by 2020. So this is just going to continue. And that's great. But I don't need to incentivize it. It's already underway. All the while that this is going on, we also know that lobbyists are going to continue to drag their feet and block any meaningful regulation and stall things, especially things around climate change or healthy building regulation or chemicals. And we tend to only focus on finishes because they're there and they're out front and we can see them. And so there's lots of healthy finishes, lots of healthy furniture, but it doesn't change the underlying toxic problem that exists underneath. So we need a paradigm shift. We need a transformation to true living materials. I'll give you an example. This is a living wall. I've done a lot of these. They're beautiful. This is a living roof, right? It's nature, but layered on top of a dead, lifeless, toxic thing. It's missing huge opportunities to really do something radical. Because imagine if the building was alive. Imagine what's possible. A building that breathes, that absorbs chemicals and CO2. A building that processes its own waste. A building that generates energy the same way that you do. For years, I've thought about how would I mimic this in buildings? How would I do this in a mimicking type of way? And I did. I mean, I built thousands of buildings like this, buildings that I used to call healthy buildings. But this is not a healthy building. It's essentially my building won't kill you, right? So it's a benign building at best. Really, it's not. But knowing what I know now, I don't think I'd call it healthy. I avoided all known cancer causing chemicals, right? But still, it's not healthy. So I kept asking myself after all these years, what do I want? What do I want? What do I really want?
Lies! Lies! Do you hear me? Give my creation life!
That's what I want. That's what life. That's what I want. That would be amazing. Real life, living buildings, building the way nature does. So that's how we came up with this idea of growing a wall because it's the earliest minimum viable product. If you can grow one wall, you can grow three more. That's really it. So that's the proof of concept. And we're already growing materials, as you'll see. We even mapped out all the other dominoes that would need to fall to get us to growing a full house. We even created timelines of how this could all work. We launched this XPRIZE, and hopefully it's going to launch next year. And then we figure it'll take 2 or 3 years for a team to complete this process. And we already have teams lined up that are interested in doing it. Very quickly after that, you'd see the first commercial use, right? Maybe as a display or an exhibit. And even during the summit, there were offers to do that. There was talk about maybe growing a pro-structure wall inside the Obama Presidential Library, for instance, as an idea. After that, you'd see other things like AutoCAD would create a plug-in, so you could essentially connect between a DNA compiler and a Revit model. You'd see other things like code approval with the ICC and ICBO, recognizing construction at least as an alternative building method. That's key to success. Maybe the best-selling Christmas gift that year would be that you would grow Barbie's dream house. That'd be kind of fun, right? Every kid would want that. And then you'd see other things. The US GBC and the World GBC would accept Prostruction as compliance for LEED Platinum automatically, or maybe ILFI accepted for Living Building Challenge. That'd be kind of fun. You'd then start to see other things like the first skyscraper, typical steel frame construction, but all the walls, all the infill are Prostruction, cutting the labor and the cost in half, which would be kind of amazing. And corn would cease to be the number one crop in this country, and soon it would be building materials. And then eventually you'd see growing a full house. And it would take a while. That's the idea. 15, 20 years, we predict. But none of that occurs until we incentivize this competition. None of this is going to change if we don't incentivize this first. Because otherwise, we've been building for 200 years. We're going to keep doing it. And in designing these prize requirements, you want to be careful. It's a bit of a fine art. You don't want to make it too restrictive that only comes up with one solution. You want to be kind of surprised and delighted by the outcome. So you don't want to just hamstring everybody. So we really design them in a way that we think gives them ultimate freedom, but gets something that would be viable in the marketplace. So here are some of our requirements. In terms of strength, it should match that of a regular wall, so it needs to hold about 300 pounds per linear foot. It also needs some insulation value, both thermal insulation and sound, because you don't want to hear your neighbors every time they sneeze. It can't weigh that much, so it can't weigh any more than 50 pounds per square foot, similar to a regular framed wall. And then that way we can use it in existing buildings too, which is very important. And then lastly, it needs to be fire rated. Otherwise, the building inspectors won't take us seriously. So we called for a 1-hour fire rating. There were other requirements we laid out. I won't go into all of them now, but it needed to accommodate a 5-inch chase so you could run plumbing or conduit or whatever you needed. It needs to be able to grow up against existing buildings, regular construction. That's very important. Otherwise, it just becomes this fringe thing that people do in the country. And then there are other physical requirements, basically, but about off gassing and about energy and about waste. But I don't want to get into that now. We even mapped out the phases of how it could work, right? So the first phase is if you were able to grow this wall over some sort of formwork or scaffold or armature. Next, if it can grow its own scaffold at the same time, the same way that your own body did, right? Because you weren't born without a skeleton. Your skeleton and your muscles all formed together. So that'd be a next level up. And then if you can add in extra biological features, that's another level up. And then ultimately, if you create that interface between a DNA compiler and some sort of design program, then there's an extra bonus. We even defined the word grow. We had to. Essentially, untouched by human or mechanical hands or means. And I know what you're thinking. You're probably thinking that it's a plant-based thing, but it probably won't be. Nature has a wealth of technologies that you could draw from, and plants, frankly, are too slow and not that strong. So we figure that teams will do some sort of hybrid or two, three, or four of these different technologies. Maybe it is got a little plant in it, mixed with bacteria, mixed with some sort of crystalline or polymer-based thing or some coral-based thing. Who knows? It's really up to the teams. Now, I know this sounds like science fiction, but it's actually possible. It's actually happening. For over 20 years now, there have been teams that have been working on this, not for buildings, but generally manipulating biology to do what it wants. And in the last 3 years, this has become really prevalent because for the first time ever, we know how a zebra gets its stripes. We know how plants heal. We know why a firefly glows. And it's all been possible through the cataloging of DNA. Just one of these ideas of nature's technology could radically transform buildings. Right? Think about your arm, right? Made of a lightweight material that thickens up at the point of highest stress. All out of a material that's 4 times the strength of concrete. And half the weight, by the way. It's incredible. Just that one thing could radically transform how we build our buildings. So that's what we're looking for, because only in construction do we use CO2 as a waste product. Prostruction uses it as a building block. Only in construction do we apply layers and layers of structure and then skin and then fixtures and lighting and plumbing and mechanical systems applied over time. In prostruction, everything grows together. Right? You weren't born a skeleton and then a building inspector came out and checked you out first, and then the team came in and added muscles, and then another inspector came in and then applied the skin. Like, that's not the way it works. It was all grown at the same time. So we're switching from construction being mass production into prostruction's mass customization. Every building could be unique because it would respond and adapt to its surrounding and its site. And we wouldn't need to paint anymore applied to the surface. Pigment could come from within. And you wouldn't even need lights anymore, right? Because the whole wall could glow if you wanted to. Imagine every building could be a LEED Platinum building or a Living Building Challenge building. It'd be baked into the DNA of it. Every surface could be a sensor or a smoke detector because it would just secrete the chemical when it came in contact with it. And the walls themselves could heal. You remove a picture hook and it heals up the same way your skin does. You could even change the color based on your mood or the time of year. It's October, so for Halloween we'll make the walls orange, right? You wouldn't even need street lights anymore because the trees could essentially light your way home. Every surface could absorb VOCs or CO2 or anything you want it to, really. And this is very much designed to work with existing buildings. And you would mix and match construction and prostruction all the time. We even anticipate that people would talk about it, right? So you'd grow your shell with prostruction and then you'd still put in your IKEA cabinets or whatever furniture you want. You'd have to. I did a kitchen for a client once, and we spent $350,000 just on the kitchen. It was gorgeous. Well, 10 years later, they ripped it out and did a new one. That's what people do. So let's grow our shell out of prostruction, and then you can build your regular things you're going to rip out with construction, right? And this very much could grow over the old buildings and restore the old buildings and then expand them at the same time. So the old buildings could become like a formwork or a skeleton for the new stuff. It could even grow to adapt its surroundings. The same way the beehives orient all their hives to north, prostruction could do the same thing with its buildings. We could even bake the building code itself into the DNA. So if you were to grow a stair, the steps would automatically be 8-inch risers. You wouldn't need building inspectors anymore. And nobody's going to miss them, trust me. And any mistakes that you make don't become waste, they become compost to feed the next batch that you then grow. So this could very much reverse desertification in that narrow band on the planet where most of us live. And this thing is really designed to grow and evolve over time. Imagine every surface a battery, a sensor, a transmitter, an insulator. It's all possible. So let's grow our buildings. Let's change this paradigm from one of cut, slash, and burn to grow, regenerate, and breathe. This is not a new idea. This has been around for a long time, as I said. It's a field that's been not talking about construction, but talking about manipulating DNA to do our bidding. And it's part of a larger set of trends that are exploding exponentially. For years, we've had low emitting materials, right? That's already passe. Then we went into zero emitting materials, zero VOC paints, zero formaldehyde added plywood, and so forth. Now we're really seeing an explosion in agricultural waste-based products. Straw board, wheat board, sorghum, right? The next big revolution that's about to occur is bio-based products. Right now it's a $65 billion market. It'll be about $2 trillion in the next 10 years. And if you look at the trends, you can see where they're headed. The next big thing is going to be living materials. It's kind of clear, and the arrow is just really taking us right there. DARPA, the research arm of the U.S. military, the guys that invented the internet, they have a biological technologies office already in place. Last year they put out an RFP for what they called engineered living materials. You can apply for it. So this is part of a larger movement, a larger trend that weaves together all of these disparate ideas that are working in silos and puts them into one big picture. It mixes cellular engineering and biology and DNA with everything that we've learned about biomimicry and cradle to cradle and living buildings and healthy materials. For the first time in human history, human beings can now cheaply and easily catalog, edit, replace, and replicate DNA, and the cost of which just keeps going down. And it's all made possible by a technology called CRISPR.
CRISPR is a molecular scalpel that we can program to cut any DNA sequence of interest. CRISPR is one of the tools that is making biology become the new digital.
Biology is the new digital. You hear that? So biologists are now able to mix and match and swap DNA code the same way that we swap MP3 files. And by the way, if you're wondering what CRISPR stands for, it's the world's worst acronym. It's don't try to remember it. It'll just give you a headache, essentially. But it's part of a larger field called synthetic biology. And every major university now has synthetic biology departments. So we looked up the hottest synthetic biologists in the world, and I contacted most of them. And these were three of my favorites, and they were really helpful with the project. Drew Endy from Stanford, and then Ron Weiss and Christopher Voigt both from MIT. And so I met with them all. And if you look at MIT's synthetic biology site, growing a house is on their to-do list. These three guys have been talking about this for about 20 years, but didn't really know how to do it. So I went there to MIT, and I met with them, and I met with Professor Ron Weiss in his lab. He was nice enough to spend a lot of time with me. This is his office. He's almost like a scientist right out of central casting, right, with the cluttered office with stacks of papers everywhere. Here's how smart the guy is. That's his lunch order. Do you see what I'm saying? Like, he's just a brilliant guy. He's at a whole other level than you and me. And we started talking about this idea of growing buildings. And every time I said something to him, he would say, oh, that's easy. So what if I wanted a surface to be a smoke alarm? Easy. What if I wanted it to absorb VOCs or certain chemicals? Oh, yeah, easy. What if I wanted it to glow or heal? Easy. In fact, I started to get very uneasy about his use of the word easy, because it's not a very scientific word. And I said, well, what do you mean by easy? And he said, we've already identified all the DNA that does those things in nature. So we could literally just drag and drop those as packages, just like we do with software. I said, okay, well, if all that's easy, what's hard? And he said, well, that's the problem. Buildings are big. We can't grow anything that big. We don't know how to yet. And then he took out his phone, and he flips to a few pictures, and he says, see this? Yesterday I grew a liver. I said, what? He said, yeah, it was pretty cool. I took some skin cells from the back of my hand. I programmed those to be stem cells, which is easy, by the way. And then we commanded those to become a liver. And I said, are you telling me you cloned your friggin' liver yesterday? Is that what you're saying? And he's like, oh, no, 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 no. This isn't a clone. This is actually a better liver. Like, my liver sucks compared to this liver. This is a whole. I said, what is it? Play chess or something? What do you mean it's a better liver? He said, well, this liver can tell us and alert us when it encounters disease, like cirrhosis. And I said, what does it send you, like a text message or something? Like, I'm an idiot, what do I know? And he said, no, no, when it encounters some sort of disease, it releases a chemical and changes color, so it alerts us. And I said, well, what do you need me for then? I mean, aren't I a huge distraction? You're growing livers, you're saving lives. What do you need me for? And he said, the liver that we grew is small. It's not a full-size liver, and that's the trouble. And then we both realized this competition is not about growing a wall. We have a lot of the pieces in place to do that. What it's really about is growing a scaffold. This is a scaffold. This is coconut husk. Nature has a lot of scaffolds. An apple, for instance, is mostly scaffold made of fiber with apple DNA in it. You are a scaffold, right? You're a skeleton draped in muscles and tissues and organs. And this is the problem. The scaffolds that the biologists use now are small. They're medical grade. They're sterile. They're expensive. What this XPRIZE really is a prize about growing a cheap, deployable, large scaffold so we can grow things bigger and more quickly. Now, when I think of scaffold, I think of this, probably the same way you do. A kind of a rigid frame that something grows on. Well, that's basically it. And nature has thousands of variations on how it builds a scaffold. So that's what this XPRIZE really is. Build us a cheap, deployable scaffold. And in buildings, it doesn't need to be medical grade. It doesn't need to be sterile. It could be old apple cores if that really works, as long as it gets the job done. So as I was talking to Professor Weiss, I said, how do we make sure that we don't get another, I don't know, Jurassic Park? How do we prevent that from happening? And he just laughed and he said, well, first of all, your building's not going to try to eat you, and it's certainly not going to chase you around a kitchen. And if it did try to eat you, it would do it really, really slowly. And I said, is that biology humor? And he said, yeah. So there you go. So if you're sitting there like worrying that we're going to invent the next Swamp Thing or whatever, apparently it's not going to happen. It's not a problem. Now the construction industry is desperate for disruption because it's not very sustainable. We have beautiful old buildings that we destroy and replace them with buildings that are not as nice. So this is our chance to kind of fix some of those economic failures of the past and update them and restore them. It's our chance to look at old infrastructure that's horribly inefficient and question it and find a new way to do it. It's our chance to look at really models like this where we've paved over paradise and put up parking lots and restore this back to something that's more useful, something that produces oxygen or energy or something else. Besides, what are we holding on to here? We're not very good at this whole building thing. I know architects get romanticized, but the truth is we're not very well liked. In fact, they even made a commercial about it.
You're working hard, you know that it's true. You need a brand new soap that works hard too. You are the worst architect in the world.
The title at the end is my favorite part. Now, if you don't believe that we're not very well liked, just Google it. These are not fake. You'll see what I mean. Nobody likes architects and contractors. Everybody I meet all over the country has horror stories about their architect or their contractor. How they felt they got screwed or ripped off or not listened to. So we're not very popular. What are we holding on to here? By the way, you can learn a lot from Googling things. Like I didn't know that you could accidentally, quote, kill your sister. I didn't know that was a thing. Anyway, so our buildings are surrounded by failures. Every aspect of them is a failure. First of all, we build most of it on site, outside. It's very hard to build things outside. Do you realize that? Go buy a model airplane and build it outside. See, you'll see what I mean. We build it outside in the rain. And by the way, job sites are incredibly dangerous. They're one of the most dangerous professions there is. I was on a job site once and I stepped on a nail and it not only went through my shoe into my foot, but then it popped out the top on the other side. And that'll ruin your day, let me tell you. And then buildings are routinely over budget and over schedule. It's become commonplace, really. In fact, we have whole meetings just to make sure how bad is it going to be. And where worker productivity has gone up in every other industry, it's gone down in construction because we're building the same way we built 200 years ago. So there's no technology here that's helping us along, right? So productivity is going down and labor costs keep going up and our profit margins keep shrinking. It's a terrible business model and one that keeps getting worse and worse and worse. And so because of that, we have no time to research sustainability or green building methods. We kind of fit it in when we can, usually in our free time or in evenings. All of these materials are mostly made elsewhere, from far away, without any sort of standard about health or anything else. And then their costs keep on climbing. And now they're externalized, so they're out of our control. We don't really have any say in it. Plus, on top of that, we're the only industry that has a 37% waste factor. Do you realize that? For every building we built, we have about a third of a building left over that we put in a landfill. That's not sustainable. Could you imagine if every time Apple made an iPhone, there was a third of an iPhone that they threw away? They wouldn't. They wouldn't be in business very long. And yet buildings are what need to change. Buildings are what must change because half of our carbon emissions are coming from our buildings. So pick your market failure, whether it's labor, waste, climate, or materials. We're surrounded by these failures. And on top of that, our buildings are not very comfortable. We're built in these beautiful, sensual curves. I mean, some of you more than others, but still, we're built in these gorgeous curves. And buildings are not. They're flat and angular and bumpy, and you hit your elbow on them all the time, and they hurt. So we need to change this. And on top of that, they're killing us. What I'm talking about here is indoor air quality. And when you think of indoor air quality, you might be thinking of, Dwayne in the cubicle next to you sneezing all the time. I'm not talking about him. What I'm talking about is when a baby crawls across a carpet, it's absorbing known phthalates, known endocrine disruptors through its little pudgy hands and pudgy legs. I'm talking about that new car smell every time we paint a room, more cancer-causing chemicals. I'm talking about the fact that the indoor air is 10 times more polluted than the outside air, which isn't very good either, by the way. Or the fact that all of you have on average about 17,000 known catalogable cancer-causing chemicals in your home right now. That's the trouble. And if you look at the sources for poor indoor air quality, 9 out of 11 of them come from buildings. Because you can choose not to smoke and you can choose not to have a cat. And by the way, you should totally choose not to have a cat. They're weird. They stare at you. They're finicky. Don't have a cat is really my point here. I'm trying to make. So we can control most of these with buildings. So we need healthy buildings now more than ever. Especially now that over the last 30 years, we've realized how they're linked to a range of diseases. Everything from neurological to terminal. Everything from headaches to cancer, essentially. And these toxins keep building up through what's called bioaccumulation. So as we're having children, we're passing on our toxins to them. The average milk, the breast milk, contains 500 known catalogable cancer-causing chemicals in it. The average umbilical cord blood has 300. And we still don't know how all of these different chemicals will interact with each other. But buildings do not prepare us for this. Now, when you go to a restaurant, there's a social contract, right? You can essentially be assured that the waiter's hands are clean, that the dishes are clean, the silverware is clean, that the food, everything on the plate is edible, including the garnish. But there is no contract like that with buildings. You can use any toxic material you want in buildings, except for asbestos and lead paint, and it's fine. And that's the trouble. Nobody regulates building materials, and in fact, all we have to do is put up a sign. But I took this picture off of a school. So it's not like the kids have a choice not to go in there. They're forced by law to. So I would argue that also environmentalism has failed. That 40 years of modern environmentalism has brought us to the exact place that we were trying to avoid in the first place. Now, I'm an environmentalist, and I have friends that are environmentalists, and I'd be the first to tell you, we're annoying. In fact, sometimes you figure the only thing that environmentalists will accept is this idea. And this plan doesn't work for me. This is not what I call a scalable solution, if you know what I mean. But what's going to change this? There's virtually no research and development in the building industry, right? Less than 1%. Compare that with what the type of R&D they do in the aerospace or automotive industries, and you'll see what I'm talking about. No candle manufacturer invented a light bulb. The post office didn't end up inventing email. If you want a transformation, if you want a revolution to occur in the construction industry, It's not going to occur inside the industry. It's going to occur from without. It's going to have to be external. And nature already has ways to build healthy, regenerative living things. We are not the first creatures to build on this planet. Lots of creatures build things. We're not the only architects and contractors here. This is the paper wasp. It builds its nest in a matter of days. It takes wood pulp from local trees, mixes it with saliva, and makes a form of cement. It can even change the hydrology of the cement based on the humidity in the air. It's amazing. This is the weaver bird. It builds its nest in a matter of hours. It takes local grasses from around the site and uses its own body as a tape measure. It builds it on this cool tripod shape and makes the opening just big enough so the weaver bird can get in, but none of its predators. It's incredible. These are termite mounds. These little critters build these things 14, 20 feet high. They excavate little holes around the edges so as wind passes over the mound, it pulls the air out through passive ventilation, a form of air conditioning. What are you holding on to here? We're terrible at this. Sometimes it's just comedic and sometimes it's disastrous, but we're not very good at building these buildings, even though we think we are. We make huge mistakes all the time. By the way, nature's not perfect either. Nature makes mistakes. Nature's builders make mistakes. Nature itself makes mistakes. Sometimes weird, freaky mistakes. Right? And that's fine. So what if we combined the best of both worlds? What if we took mankind's cleverness and ingenuity and mixed that with nature's technology? It's not a bad idea. Mankind does cool things. Like, for instance, I love my Dyson vacuum. I love it. Sometimes I just hold it for no reason. That's how much I love it. Or the fact that we invented this. These nose strips. I love those. I love to peel them off and then I leave them around for my wife to find. It's amazing. Or what about this, that we invented this? By the way, those are pretzel roll hot dogs. Those aren't just normal pigs in the blanket. Those are pretzel roll. That's amazing. So imagine if we took that ingenuity with with nature's technology. That would really be something. My old mentor Malcolm Wells drew this in the 80s. And it's he did it kind of as a joke, but it's a pretty strong idea. You grow your house, and then if you get married and need more space, you plant another seed. And then if you guys have kids and you need more space, you plant another seed. That's the way it should work. In fact, Wired Magazine recycles this joke every few years, right, with seed planting buildings. But there are architects that are working in this field. This is Mitchell Joaquin in New York, who helped advise us. He's using pleaching, where he's taking live trees and bending them to create structures. There's lots of architects working on this idea of growing, living buildings. This is David Benjamin, also in New York. These are mushroom-grown bricks. So it's essentially mycelium bricks that are grown and then placed by robot in a very specific pattern to build a structure. This is Neri Oxman at MIT. She commanded silkworms to be her contractors, and they built and to build for her what she wanted. And besides, this is a huge, perfect piece that complements what's going on in synthetic biology. So while the biologists are trying to create designer pets or whatever the hell they're doing, we're just going to grow buildings, beautiful, healthy, abundant buildings for everybody. So it becomes this perfect stepping stone to incentivize and revolutionize and market this technology. And putting this XPRIZE together, we had the help of lots of great, amazing folks that contributed their ideas and enthusiasm and expertise, and I know you recognize a lot of names on that list. We also had the support of other great organizations. UL came on board and offered to provide testing services to all the teams for free. Autodesk gave us access to their digital fabrication studios in Boston and San Francisco. And then Lacey said that they would provide lab space for all the teams for free if needed. All told, it's about $2 million worth of services they've just donated to us. The Biomimicry Institute said that they would provide technical support to teams. Building Green said that they would provide go-to-market support. Ecovative, the people that grow the mushroom bricks, they provided samples for the room, which was amazing. I had a podium made out of grown mushrooms, which was kind of fun. We even reached out to our friends at Apple and said, wouldn't it be great if our Apple Watches measured how much time we spend outside, not indoors breathing chemicals? And they responded and said, we'll look into it, which is, for Apple, is huge. They normally never respond to anything, so that we were very excited just to get a one-line email. Harvard's Graduate School of Design is on board to advise computational design for structural robotics stuff. Interface Carpet said that they want to grow carpet, so they've come on board as advisors to that, and they're willing to license whatever that winning team comes up with. The BioBricks Foundation let us use their open source agreement for DNA to all the teams, so that way all of this is open source to everybody. We even had a design competition with our friends at Inhabitat and some all-star judges, and we asked people to show us what Prostruction could look like. And so we received hundreds of entries from 14 countries. It was kind of amazing. And some of them are just totally fantastic and incredible, and some look like, pretty traditional looking buildings, but grown on the site. And it was just an incredible experience. And we had these displayed in the space that we created. And you can see the rest of them online. These are just a few of my favorites. So that's it. That's the power of using nature as a technology. That's the power of putting nature in your mindset to create a paradigm shift. To think about that, because that's what nature really is. Nature is a technology. 3.8 billion years of research and development. You've heard of better living through chemistry. This is better living through biology, essentially. This could radically transform everything and even save the 7 million people a year that die due to toxins exposure they get just from inside their homes. So let's grow our buildings. Let's embrace this idea of prostruction. Let's grow healthy buildings for everyone, everywhere. Cheap, abundant, healthy buildings. Or as President Trump likes to say,
and I said, we need to build a wall, and it has to be built quickly.
Quickly, hear that? Quickly. So let's do it quickly. Let's go. Let's do it. Grow us a wall. Have it match the properties of a regular wall. Add in some biological features. Do this in 6 months. Win $10 million. Doesn't that sound good? Doesn't that sound exciting? If we launch this prize, we're building a future of beautiful, abundant, healthy buildings for everybody that could radically transform our health and our relationship to nature. And that is the pot of gold at the end of the rainbow. That's the definition of victory, not just for Americans, but for everybody for the 21st century. The last slide that I showed at the summit on the last night was this one. And Lowe's, who had sponsored the development of the prize up to that point, had generously agreed to sponsor the entire prize after that, the entire 10 million. So that was kind of nice, and everybody applauded, and some people cried, and it was kind of nice to see. But what they've been doing has been kind of amazing, and I'm not trying to plug Lowe's. I'm just saying that they have this whole innovation lab that's incredible and has been incredibly supportive of this work. So with that, I want to thank you for your time. I want to thank you for listening. If you want to follow along on the adventure, you can go to prostruction.construction.com, or you can follow on social media with hashtag HealthyHomesXPRIZE, and you'll see hundreds of articles that we've posted that kind of show this movement taking place. Otherwise, thank you for your time. Thank you so much, and I look forward to talking to you soon.